Okay. Are we all good? Okay. Welcome to the survivors. I saw we had about a 30% attrition, which is not unusual for these classes, but that's okay. So, and some of it too, my hunch, they've offered actual apologetics classes here before, right? Does anyone know that? Yeah. So that's probably, to a certain extent, what people were looking for. So, which is good, but maybe we'll do that next summer. So, welcome to number 2. Shall we open in prayer? I think that's a good idea. Lord, I thank you for today, and I thank you for bringing everyone here safely, and I pray that you'd help us to listen with open minds and open hearts, and be willing to ask questions, and not settle for easy answers when the easy answers aren't forthcoming, and to be satisfied with lack of answers when there are no answers. And we thank you, Lord, that you know each of us individually, and you know what we know, and you know what we need to know. And we thank you that you are Lord of all those things, and pray that you would help us to listen to you today and listen to each other. And we ask all this in your Son's name. Amen. Yeah. So, just to give you a little idea what the schedule is, we've got a few things to go through, then we'll do kind of a little small groupy activity. If you're at a table all by yourself, then you might want to go with someone else, at least temporarily. But we'll get there. And just to remind you of the schedule, last week was sort of more of a general introduction of, what is science, what is this class all about? The key word being, if you came away with nothing else, it's that hopefully and historically, people have always appreciated that there's 2 books, the book of Scripture and the book of nature. And at least in theory, the 2 should never conflict with one another. So, and when they do conflict, it's probably either you got your science wrong, you got your Bible interpretation wrong, or you're just not very smart. No, I'm kidding about that. Although I guess that is a possibility too, but we'll assume that's not the issue. So today, this is going to be in some ways a little less Bible focused. I say that, and then in about the last half hour of class, you'd be like, wait, I thought you said this would be less Bible focused, and here we are discussing the Bible. But it's a little bit less anyway. So what we're actually talking about today is what is science. Unfortunately, there's a couple of people that emailed and said, they can't make it this week and they can't make it next week, but they're looking forward to the last 2 sessions. That's great, except unfortunately the last 2 sections rely a lot on what happens this week and next week. So it'll be your job to catch them up on what happens when the 4th week comes around. So the issue is, what is science and why does it matter? Who here doesn't know who these people are? What? Okay. That, of course, is Kermit the Frog. And who's the tall guy? Beaker. And who's the short guy?
Bunsen. Dr. something.
What's his full name? Dr. Bunsen Honeydew. Yes, there's an entire Wikipedia on the Muppets that will give you his entire backstory if you're really curious. So they are the head of Muppet Labs, so they do all the research for the Muppet Show. So it usually involves setting Beaker on fire or blowing him up. And in more slightly closer to the real world, but not by much, here's your Science Lab movie starter pack. So, and here it is, and this whole list of things here could be extended indefinitely. Lab coat but no gloves, or gloves but no eyewear, or pipetting things by mouth, tubes of colorful liquids, machines that if you look at them closely and you know what they are, they have absolutely nothing to do with what's happening in front of the person, but they got them on sale somewhere. Microscopes used for everything, or sometimes telescopes pointed at nothing. You've got to have clipboards. Pictures of DNA, of course. Yes, and all men are mad scientists and women are supermodels. That's pretty much a given. So the point of this is that popular science is almost a contradiction in terms. That you can be popular or you can be scientific, but you probably can't be both, at least not in a realistic or veridical sense. But we'll get there. So a lot of you probably remember this from your junior high science classes, your first biology class you took in high school. What is science? It's a way of knowing how things work in the natural world. The ideal is that it's an objective and universal understanding. Theoretically, whether you speak Japanese, whether you're living in South Africa, whether you're out in the Amazonian jungle, then science is supposed to be the same for everybody, everywhere, all the time, through all of history. The only difference is how much of it you understand. And a lot of you have probably seen something like this. This is the idealized picture of what you're supposed to do if you're a scientist. You make observations, you research that area, you form a hypothesis about something. You test it with an experiment, you analyze your data, and you report your conclusions, and it just goes around and around and around. And if you do this enough, eventually you create a scientific theory. Now, this is highly idealized, as we'll spend the next 20 minutes talking about. My only other pet peeve that I want to mention is, who here feels good about defining scientific theory for me? I'll call on people if I have to. Because I know who knows, and they're just being shy. But anyway, if you do enough experiments and enough hypothesizing and publish enough and a series of hypotheses gets enough support from enough people, it becomes a theory. So what a theory is not an educated guess. It doesn't mean, well, I don't know, it sounds good to me. That's not a theory. A theory is, for an example, germ theory. Who here believes in germ theory? Who here believes you should wash your hands when you leave the bathroom? Whether you do it, I won't ask if you actually do it all the time, but who here thinks at least that you should? Okay, yeah. Most everybody. So you believe in germ theory, even though it's only a theory. Now, where of course this gets contentious is, I don't know how many conversations I've been in online where somebody says, well, evolution is only a theory. And all the Christians go, yeah, it's only a theory. And all the science boosters go, yeah, it's a theory. And they just completely talk past each other. So don't be that person. So make sure you know what you're talking about. A theory is not a scientific fact. Most people will say scientific fact is something that you observe. So it's raining outside is a scientific fact. Why it's raining, you could say, well, because the humidity is above 100%, and that's my hypothesis, and I can test it by testing the humidity. And if you test the humidity enough times when it's raining outside and it's always above 100%, you can make a tentative guess that maybe high humidity results in rain. Or alternately, you could guess that rain results in high humidity. So this is a drum that I'm going to bang over and over again over the next 20 minutes. Trust the science is often an assumption of modern society. And I mean, this is true everywhere. This isn't just true out there for those people, it's true inside the four walls of this building also. That again, even though you're in church, you still wash your hands after you go to the bathroom, or are supposed to. Article that is here mentioned concerns, I'm not going to be able to tell you his name. He recently constructed a steam-powered rocket that he was going to fly into the stratosphere to prove that the Earth was flat. He got the rocket up to about 600 meters and crashed and died. Okay, does he believe in science? Well, he obviously thought the Earth was flat, but how did he test that hypothesis? Did he test it by going into a trance and realizing, based on his assessment of the Akashic records, that a being of pure light appeared to him and told him that the Earth is flat? No, he tried to fly a rocket up into space. And that's how he was. So he was still a believer in science, he just didn't believe that particular bit of science. So this is everywhere, all the time. And this includes in the church. But we'll get to there. We'll get there in a second. So, and again, public science is usually not science exactly. Real science is pretty much invisible. So unless you yourself are a scientist, work in a laboratory, work for industry, work for a university, you don't actually see any science. And you say, but it's on the news. Well, yeah, kind of. It is kind of on the news. But it's digested for you. It's kind of like thinking that food comes from the grocery store. It's like, no, food comes from the farm. You buy it at the grocery store. You know, science comes from science labs, but you just buy it from the media. And this is, something that we're going to discuss in depth in a minute. Good science reporting is rare and hard to do. Again, something a drum that I couldn't bang hard enough is the idea that if it's an influencer on TikTok and he's telling you about science, then there's about a 98% chance he doesn't know what he's talking about. So now there are the 2% of people who actually do, and fortunately they are sometimes some of the more popular people. But that's not a sure thing. And here's a slight hint. If you can't figure out who it is who's talking to you or what their qualifications are, they don't have any. So there are actual people who actually know about sciencey stuff. Most of these people, I know we kind of talked about this, the guy in the upper left, Carl Sagan, actual PhD astronomer guy, sometimes spoke a little out of his field, but he was talking about astronomy. He knows about astronomy. Neil deGrasse Tyson to his left, similar. Bill Nye, the science guy, kind of borderline in my opinion. Does anyone know Bill Nye, science guy's actual background? He has an undergrad degree in environmental science. That's not nothing, but he's not a scientist, he's a science popularizer. The same is even true for, is it Adam Driver, is that his name? the guy, the Mythbusters guy. If I'm not mistaken, I think he might have an AA degree in anthropology or something like that. So, but I mean, he's a media personality. And again, that doesn't mean he's wrong. Doesn't mean you shouldn't believe what he says about science, but kind of take it with a grain of salt. Stephen Hawking in the middle. Again, obviously real scientist. But, well, we'll talk about that in a minute. And then lower left, she goes by the name Gutsick Gibbon. The good news about her is she is an internet influencer. She's on YouTube, she's on TikTok. However, it's not hard to figure out that she actually does have a PhD in physical anthropology and actually kind of knows what she's talking about most of the time. She has chips on her shoulders as well sometimes, but it's usually pretty decent. But again, the whole point is you can find out what these things are. If you can't find out what somebody's qualifications are, then they may not have any, or at least none that they're willing to share. So, and all of this is not to say that you shouldn't read science articles or listen to science publications or listen to science blogs or watch science TikToks or YouTube. It's just, to take it with a grain of salt and use it as a starting point, not as a conclusion. I'm saying more of the same thing. It's essentially visible to people until it hits the news cycle. There tends to be an inverse proportion to how likely something is to hit the headlines and how accurate it is. There are rare cases. COVID was hitting the headlines. Was COVID a big deal? Yes, COVID was a big deal. I can pretty much guarantee you that the next headline you see, and there will be one in the next 3 months, giant asteroid set to hit Earth, is probably not going to be actual news. What it probably means is that an asteroid is going to pass within 5 or 6 million miles of Earth, which is only about 20 times as far away as the moon is. So if you're worried about the moon hitting the Earth, then you should probably worry about that. Otherwise, don't worry about it. So has anyone ever seen a chart like this? There's a media company called Adfontes, Adfontes, that rates news in general, and this is an effort to kind of be like them, in the sense of the higher you go up into the upper left, the upper left, the more likely you are to get news that is both interesting and accurate. The farther you go in the lower right, the more likely you are to get stuff that might be really fascinating and really, wow, that's whiz-bang stuff and is probably wrong. So that's not to say that everything that Food Babe tells you about your food is necessarily wrong, but again, at most it should be a starting point. If she says seed oils are bad, well, maybe you could spend 10 minutes looking into the idea of seed oils are actually bad, and if you can't find out anything about seed oils, then she's probably making it up. On the other hand, my favorite one actually in here, which I put on your piece of paper, I think it's just called Science News, is pretty mainstream, pretty interesting, and pretty accurate. The stuff in the lower left, if you're looking for something that's hardcore science, then it's there, but even further down to the left, kind of falling off the chart, are actual journals. The American Journal of Astrophysics is falling off the lower left-hand category, so it's real science for sure. You probably won't understand it and won't find it interesting if you do. Unfortunately, that's actually where the real science is happening. So the more digested it gets, the more it moves up and to the right. So why don't we take 2 minutes, 7 minutes. Is anyone at a table where no one has an article that other people can look at, or can at least show on your phone, or can describe? Does everybody have something like that? If you don't, I can get you a substitute article. On your little piece of paper, you see some questions. Mm-hmm. So ready, set, go.
Which ones? 1, 2, and 3?
1, 2, and 3.
Okay, 7 minutes?
Yeah, well, okay, 10. The good news, bad news is, the bad news is, okay, you don't really know what to do with that. The good news is that that's probably actual science-y stuff at that point. Again, if it's like, stop eating seed oils because you're going to get Alzheimer's tomorrow morning, then it's probably not science that you're talking about. That's not always true, but I hate to put it this way, but a lot of really, especially the more pure science, is really, really boring and irrelevant. And in my own field, you will have people that will spend their entire career studying a particular receptor on the cell membrane of a neuron. And at the end of their career, they will know that, hey, the cyclic GMP actually has a slightly different conformation when it enters type C cell fibers than when it enters type B cell fibers, and this could lead someday to more effective treatments for pain. And you're like, wow, that's great. Where can I buy this treatment for pain? Well, it might be available in 15 to 20 years, maybe, if it all pans out and it doesn't cause cancer and it actually works and it's not too expensive and we can find someone to manufacture for us and someone doesn't beat us to something that's more effective first. Okay, well, hey, thanks for sharing. So, unfortunately, there's a reason why everybody wants a Nobel Prize is because very few people actually get them. So, what did you guys talk about?
Fabrics like polyester can contain a number of chemicals that might impact fertility.
Yes, and I don't know if this is what related. There's a lot of talk recently about, microplastics. Microplastics are going to kill us all. And of course, what I tell my kids is I had to grow up being worried about nuclear annihilation. They need to be worried about something. And hey, we still have nuclear annihilation as a possibility too. But anyway, what was your assessment? Are you worried about the shirt you're wearing?
No, not polyester.
Oh, not polyester. See, there you go.
Well, impacting fertility, I really don't have to worry with that.
Well, yeah. That's true, yeah.
It made me want to learn more because I really didn't understand what her qualifications were. But the things she said seemed pretty apropos.
Yeah. And that's, that would be my advice is, this is a good place to start. Just don't walk away from the article saying, I'm going to go home and immediately burn all of my polyester clothes. So maybe you should, maybe you should, but we certainly don't know enough yet to do that. So what did you guys talk about?
Well, everybody found something. Mike found one on dinosaur guts.
Oh, yeah. Yeah, I think, did you send that to me?
Yes, I did.
Oh, yes, you did, yeah. Yeah, although I didn't have a chance to look at it very much. What was your assessment of the title of the article? First,
It's a good study. It's very lightly touched by the newspaper article. The title says more than the study actually says, and it's irrelevant, and it's interesting, and
first fossil proof found that long-necked dinosaurs were vegetarians.
not all of them. They
Yeah,
went to
yeah.
some trouble to say that only the one that they found
Yeah, and
surely ate big chunks of green stuff.
yeah, and that is very, very, very typical for popular science reporting. That we have discovered that this particular fly, which lives in Namibia, has severe impacts on a local cattle species. Therefore, we should all be afraid of the flies affecting our beef prices. It's like, no, there's like about 15 jumps in there, maybe 20. So, and again, now that's not to say that that's irrelevant. If there's a fly in Namibia they discover that's affecting cattle, and that it's because of some mutation in that fly, and that mutation is found to be able to spread to other flies, and now they discovered it in Kenya, and now there's also a fly in Sardinia, and now there's also a fly in India that has the same parasite in it, and it's starting to, then maybe you should start to be worried, and maybe you should start going short on your cattle futures. But again, that's at least 6 or 7 steps down the road. So what did you guys discover? Oh, was this the other, the Dead Sea Scroll one? Mm-hmm. What did you think? I know it didn't have very long to look at it.
They did kind of tell both sides of the story as far as analysis goes. And they had some different professors they interviewed. So that was good, I guess.
Yeah. The again, something that I think I put on one of the slides, hopefully, one of the marks, at least I think, of good science reporting is if you can find the original research article. If it's just this sort of vague hand waving toward, hey, here's something that some scientists did, then, okay, that might be interesting, but it's pretty much fluff. If it's, here's a link to PubMed, here is a link to the International Astrophysical Journal, here is a link to the American Journal of Physical Anthropology, then you might actually have something there. Climate change is coming for your cheese. Well,
Because of the drought in France,
okay, because of the drought in France.
they're having to supplement the cow's food and trying to decide if there's, and so it's still in the experimental, so they're still, running research on it.
Mm-hmm.
To what feed will produce the same amount of milk and the same kind of cheese that they're used to.
Yeah. So and yeah, and I appreciate you got to get clicks, you got to sell news articles, but the drought is coming for your cheese is obviously kind of, but to their credit, I don't think anybody really looks at that headline and immediately runs to Costco and starts buying cheese.
Right. No,
So yeah, yeah. So I mean, I don't want to be too harsh here. If it's like, an asteroid is going to hit Earth tomorrow morning, then okay, nobody really thinks that's going to happen, or unless you turn on the news and it's on every news channel and NASA is scrambling and the president is issuing a statement and 2 minutes later, there's that obnoxious little noise that comes on that tells you to head for your basement. Okay, then maybe an asteroid actually is heading for Earth. But most of the time, that's not going to happen. And again, most people know that if an article is too good to be true, it probably is.
Well, climate change is happening around us all the time.
Yeah,
The way the cows will adapt.
yeah. Well, yeah, and we'll still have cheese. It may not be the same cheese, but it'll still be cheese. AI handwriting analysis finds Dead Sea Scrolls may be different than archaeologists thought. And it is kind of interesting, and this is actually pretty, I would argue, is pretty decent reporting because the headline basically says, yeah, it uses the word may in there. It may be different. It may not. So essentially, if you read through the article, what it says is that there are some interesting things, like some of the scrolls that the AI thinks they were written by a pair of scribes. And this is actually a pretty hot area in ancient manuscripts, is trying to figure out which scribe did what, because there were relatively few of them. And particularly in a community like where the Dead Sea Scrolls were found, there were probably even fewer of them. So to find out that there were two of them, they were kind of working, probably at a desk next to each other, is actually kind of interesting stuff and has some effect on how you interpret the manuscripts. So, and some of another thing that makes it kind of good science reporting is this isn't necessarily whiz-bang. Now again, just because it's whiz-bang doesn't mean it's wrong, but to test the program, they gave the AI 135 manuscripts without dates. It agreed with the estimates scholars made 79% of the time. So in other words, humans are still getting it right 80% of the time. And if you look deeper into the article, the other 21% of the time, they were maybe 50 to 100 years older than they thought. And if you look even deeper in the article, and especially if this is something that you really like, wow, I actually want to learn more about this, then you go to Google and you punch in AI Dead Sea Scrolls and you find a different reporter who wrote a different article. What you'll frequently will find is this exact same article, word for word, is regurgitated across multiple platforms, and that doesn't do anything for you. But if you actually find somebody who ideally is writing it from a completely different angle, then you may find something different and interesting. And what you'll find is the other 21% of the time, were they older? Well, it depends on what you mean by older. Were the manuscripts older, or was the text older? Or was perhaps even one of these scribes intentionally using an older technique to make the text look older? Not to fool people, but just kind of like how, we might use Elizabethan English to sound more profound. If you're praying and someone starts using the these and thous, they're really getting into it, that kind of thing. So anyway, this would be an example, I would say, of decent reporting. On a 0 to 10 scale, this is probably an 8 anyway. That it doesn't overstate things. There's not as such a link to the direct research article, I don't think. Oh, there was, okay. But there is at least enough information that you can find one. And unfortunately, if you have a link to the actual research article and it's behind a paywall, I don't know what to tell you. 80% of the time, that's a good sign. It means it's a reputable journal that has certain standards and doesn't just publish for anybody. It can also mean that it's a pay-to-play journal that's just garbage. So most of the way to figure that out is to see how old the journal is. If it was publishing before 1990, it's probably pretty reputable. If it sprang up 3 years ago, then it's probably just garbage. So the question is, if science isn't just observe, hypothesize, experiment, publish, then what is it? Well, first of all, there's the question of what is science? This is, the technical term for this is the demarcation problem. Where do you find science where it stops being science and starts being, well, pseudoscience is the term you'll hear for it. Most philosophers today, and by philosophers I mean philosophers of science, have kind of given up on the demarcation problem. This is an XKCD. Anyway, it's a webcomic, and you will sometimes see something like this. That psychology is just applied sociology, psychology is just applied biology, biology is just applied chemistry, chemistry is just applied physics, and physics is really just glorified mathematics. We'll talk about more in this last section. I mean, that assumes materialism is correct. But it highlights the idea that every scientist can look at some other science and say, well, that's not really science. The ultimate whipping boy is economics, which most economists will tell you is a real science, and pretty much everyone else will tell you is just hand-waving and wishful thinking. So I don't know. Like I say, most scientists have given up on the demarcation problem because it's just not particularly soluble. Here's the way scientists actually do science. You start in the far left, make an observation, form a hypothesis, lose interest. Or you make a prediction and take a nap. You test the prediction, your hypothesis is supported, and you publish results, do a little dance, make a little love, and get down tonight. Or hypothesis is unsupported, and then you throw a tantrum. And obviously this is a joke, but this is kind of a little more what it actually looks like. It mostly highlights the idea that science is still a human venture. We are not yet at the point where AI is doing science all by itself. We'll talk about that in the last class. Maybe then it will be a little more predictable. Well, probably not. All actual scientific research is done with questions not only like what did I see and how does it make sense and how do I fit it in with everything else. It also is mixed in with a bunch of other questions like has anyone done this before? What will my lead researcher, the administrator, or the grant administrator think of this? Can I get funding? What is the likelihood of a positive result? What if this study tells me something I don't personally like or that my fellow researchers don't personally like or that they will think I'm silly for pursuing? How likely is anyone to check my work? All these things kind of get factored into any research program. Now, anybody who gets as far as a PhD in anything in the sciences knows what science is supposed to be, but part of the whole process of getting a PhD in science is realizing also what science actually is. That you can be the most brilliant person in the world, but if you can't write a grant application, then at best you're going to be working for somebody else. And that's, unfortunate, but that's kind of the way it works. It is still a very human venture. So how did we wind up in this position? If it's 1750 and you're a wealthy European and you have, sort of Downton Abbey style, that's more 19th century or 20th, then you have enough money to build a lab in the study of your own house. And you have somebody who knows how to blow glass, and he will make all of your instruments for you, and you will experiment on them. And if, true story, phosphorus was discovered in 1740 by a Frenchman who collected several thousand gallons of urine. Where did he get it from? He got it from everyone on his estate. So Marceau, what are you doing today? I'm peeing in a cup for my master. Okay, well that's, he's saving urine. Oh, how interesting. Now, and of course what he did was he took thousands of gallons of urine and he basically set it out to dry. Imagine being downwind from that. And what he wound up with was a couple 100 pounds of powder, which was, mostly yellow crystalline stuff, and purified it through a long process and came up with stuff that he found out glowed in the dark. He had discovered phosphorus. Now, how did he know to do that? He didn't know he was going to do anything. He was doing this at the same time he was doing a dozen other experiments that probably included, horse dung and cow bile and who knows what else he was experimenting on. But this one happened to work out. So those days are long past. So no one does this anymore. No one has servants that can blow glassware for them. So science these days is never really a process of I observed something, I made a hypothesis, I'm going to do some experiments, I'm going to figure out how it works. That is idealized, and once in a while you still see somebody who does that, who's really walking through the woods and notices that a bird is doing something strange and notices that that's the third time they've seen a bird doing this in this particular part of the forest, and they come up with some hypothesis about how smart the bird is. That occasionally happens, but that's very rare. Most science today is big science. So that means you're going to be working for a lab, you're going to be working for a company, you're going to be working for the government, you're going to be doing something for someone, and they're kind of going to tell you what to do. So this idea of just doing science in your lab, it pretty much died around 1900, 1850. To make matters worse, during the late 19th century, there was, early 19th century, there were problems with induction and causation. Two big words. Basically, if I throw a rock at a window, what happens? The window breaks. How do you know the rock broke the window? Strictly speaking, you don't. You can say, hey, every time I pick up a rock and throw it at a window, the window breaks. At which case, the philosopher Hume points out that you have not thrown every rock at every possible window in the universe, so you cannot say that that's what always happens. The most you can say is that usually, in your limited experience in this little tiny corner of the universe, When you throw a rock at a window hard enough, that window appears to break. And of course, most scientists looked at this and said, that's a very valid point, but if we carry that to its logical extreme, we can't do science anymore. At which point Hume said, yeah, you're right, okay, never mind. So this is one of those little problems, kind of like the demarcation problem. Philosophers of scientists looked at it and said, we don't know what to do with this, so let's stop talking about it. And induction is similarly. Induction is just a fancy way of saying inference to the best explanation. If you came here this evening and you were running a little behind, you got here about 6:40, you walked in here and the lights are all off and it's completely empty and there's no one here. You say, okay, and you walk around, you go upstairs, you walk around and there's nobody anywhere. You figure, okay, maybe it's in the other building. You go over to the other building, all the doors are locked. What is your assumption?
Jesus came back.
Yeah, yes, I know. The rapture happened and you didn't make it. Probably, the more likely one is that, class got canceled and nobody told you, you didn't read your email, you didn't get the text, whatever. So that would be your inference to the best explanation. Now, it is possible that maybe the rapture did happen. That's not completely out of the question. Maybe you did get left behind. That is theoretically possible, although we probably would have left the lights on. But science is always a matter of inference to the best explanation. This is both a bug and a feature. It means that science is always flexible. So you can always change your mind. There is a small, but it's possible that the germ theory will be overthrown tomorrow. That polio is not caused by polio virus, it's actually caused by bad humors in the air that gets around, and it just so happens that the polio vaccine immunizes you against the bad humors, and these bad humors encourage the production of this polio virus that has nothing to do with the disease. So for a while, this was actually a theory that you'll still see it around about HIV, that HIV doesn't actually cause AIDS. Well, if you want to go for that, you can. Certainly the scientific consensus is that yes, HIV causes AIDS. That if you get HIV and you don't take your antiretrovirals, you sooner or later will die of AIDS. Now, can someone come at you and say, yeah, but we don't know that that's actually been 100% proven, now do we? Then you can say, well, science always works inference to the best explanation. What we do know is that everyone who has a sufficiently high level of HIV in their blood eventually develops AIDS and dies from it. So and people that don't have HIV don't get AIDS. So you do the math if you want. But strictly speaking, nothing is proven in science. I don't know how many, mostly online debates, this is where these things flourish, where someone says something like, I bet you can't prove that God exists. To which I say, yes, it's true, you can't prove God exists. You can't prove that the universe wasn't created 5 minutes ago with the appearance of age. You can't prove that you're not talking to an alien who's pretending to be a human. There's all kinds of things you can't prove, and strictly speaking, you probably can't prove anything. However, the reality of the situation is that some things are much, much more likely than others. So the likelihood is that HIV really does cause AIDS. What happened as a result of some of these cogitations are these two guys came along, Karl Popper and Thomas Kuhn. Has anyone heard of either of these names? Yeah, yes. So Karl Popper was a successor to the empiricists. So the empiricists were people that had said, science is a matter of observing scientific facts and proving theories. We have a fact, we make a hypothesis, it creates a theory. That's science. Unfortunately, Hume came along and said, these are all just educated guesses. It's all a matter of statistics. Science is always tentative. And Karl Popper came along and said, you're absolutely right. What makes science science is if a theory is falsifiable. The two primary examples he used is Einstein's theory of general relativity and Freud's theory, some of his theories behind psychoanalysis. Or he also used Marxism. I know a little bit more about the Marxism thing. He also says that Marxism is an economic theory, but it's not falsifiable and is therefore not science. The classic example with Einstein is what became known as the Eddington experiment, which is in 1918. I don't know how they did this in the middle of World War I, but they traveled down to South America and measured how the stars shifted their positions in response to gravity from the sun during a solar eclipse. That's the time when you could see the stars really close to the sun. So they measured it was 1.36 arc seconds was the amount of deflection of a couple of these stars. That was showing that light was bent by gravity, which was one of the predictions of Einstein. Now, basically, if the light had not been bent, if the stars had not moved, then Einstein's theory would have been falsified. Therefore, Einstein is good science. Now, when Marxism came along, the Marxists said that highly industrialized societies will undergo a revolution as the workers realize that they are not in control of the means of production and are being oppressed by the bourgeoisie. And of course, where did the first communist revolutions actually happen? In Russia and later in China, both of which were not the slightest bit industrialized. Where did those revolutions not happen? England, the United States, Germany, which were right at the edge of the Industrial Revolution. Marx, or at least his followers, said the reason for that was, first of all, that the governments of these highly industrialized nations were running scared and made changes so that a revolution didn't happen, and that these things spread into these unindustrialized nations who saw their future coming and said that we need to have a revolution now. Karl Popper looked at that and said, that's the definition of non-falsifiable. All you're doing is moving goalposts to make your theory remain true. So that was Karl Popper. Now, just the difficulty is that it doesn't really help any. In other words, for instance, let's take the HIV example one more time. Can you prove that HIV always causes AIDS? Is there someone out there who has a high level of HIV in their bloodstream who does not get AIDS? No one that we've seen has a high level of HIV in their bloodstream who does not shortly get AIDS. Does that mean that that doesn't happen anywhere? Well, no, because the reason we test people for HIV is because they're sick or because they're at risk of getting HIV. So maybe there's someone in the Himalayas somewhere who has a lot of HIV, has had HIV for years and doesn't get AIDS. So you're saying that theory can't be falsified. I like the idea of falsified. Okay, well, you can't prove it though. Okay, so now the problem is that Popper, it was a helpful criterion to think about, but it doesn't actually help much in the long run. Then along comes Thomas Kuhn, the structure of scientific revolutions, and he particularly looks at things like the Galileo controversy, some things having to do with quantum mechanics, and basically points out something which is now kind of orthodoxy in the philosophy of science, which is to say there is no such thing as empirical observation. You don't just look at something and think about it and record it and write it down. The theory is, and this gets, okay, you ready? Ready to have your head explode? All observations are theory laden. That's a fancy way of saying that no one just looks at something and sees what it is. You're always going to look at something and put it in the midst of a pre-existing system of beliefs. When I look at this table, I see 6 people ranging in age from 23 to 55. Okay. Who are amicably sitting next to each other, presumably as part of a class. Now, is it possible that these 6 people were sent here to assassinate me and they're just waiting for their perfect opportunity? That's not impossible. What do my observations tell me? My observations, strictly speaking, do not say that's impossible. They look pretty friendly, but that's exactly what assassins would look like. So my observation that they are all sitting here politely listening to me talk up here is theory laden. We're in a class. People are presumably here willingly. They're not being paid to show up by the mafia or whatever. So my observation of them is colored by that pre-existing theory. Another classic example of this is, and this is reasonably well documented, there's some crazy stuff out there that is not, that's very similar. When the Spaniards showed up in Peru on horses, the Incas weren't quite sure what to make of that. The biggest animal they had ever seen were large llamas, which are about half the size of a typical Spanish horse and about 1/3 the size of a large horse. And you can't ride a llama, realistically, except maybe as a joke, because the llama will kick you off in about 2 minutes. So when the Spaniards came riding horses, the observation the Incas made was that these were semi-divine beings or monsters being ridden by demons. Now, is that correct? We would look at that and say, no, they're just Spaniards on horses. No. Now, of course, the Spaniards realized fairly promptly how they were being viewed and, unsurprisingly, took advantage of that. So yes, we are monsters, and you better do what we tell you. So, but again, that's an example of how the Incas weren't just looking at the Spaniards and saying, hey, it's a guy on a big animal. It was in the midst of pre-existing assumptions about how reality works. So all scientific observations are really in the same category. So what the heck is science anyway? And here's my, my provocative thing. Science is like pornography. What I mean by that is some of you may, if you're old enough, you remember a discussion in 1964, Supreme Court Justice Potter Stewart in the case Jacobellis versus Ohio, which was an anti-obscenity statute that was challenged on First Amendment grounds. Supreme Court Justice Stewart said, I shall not today attempt further to define the kinds of material I understand to be pornography, and perhaps I could never succeed in intelligibly doing so, but I know it when I see it. That's about where the demarcation problem stands today. What is science? Science is what you think it is. If it looks like science, it probably is. Now, the caveat to that is that you probably need to have some significant background in science in order to tell the difference. So if you're a 17th century Incan, you probably don't know much about what science is. If you're a 17th century Spaniard, you probably don't know much. If you are a early 21st century person with a PhD in mechanical engineering, you probably do know what science is. Okay, you ready to have, okay, I promise this is as weird as it gets. Are any of you familiar with this meme format? Probably, if you're under 30, you might be. So the simple way to put it, science is any organized field of knowledge. That's the old version, that's going back to 1800s. Economics is a science, astrology even was a science back in Newton's day and before that. Well, after they got rid of that, science is empiricism wedded to careful observation. That's 19th century. No, actually, science is an organized collection of falsifiable propositions. That's Popper. No, science tells us nothing of reality, but is just in the business of creating useful models. So this is early 21st century philosophy of science that even philosophers of science look at this and say, oh, you're one of those people. So I don't necessarily believe this, but it's interesting to consider. That, I don't know how many internet debates I've been in where somebody says, science is in the business of describing reality. You want reality? Go to science. You want to know about reality? Talk to a scientist. And then it's always kind of amusing to say, actually, science doesn't describe reality. All science does is come up with theories and models that lets us predict behavior. When I throw a rock at a window and science says that the kinetic energy of the rock is involved in breaking chemical bonds within the glass, and therefore the glass falls apart and shatters, is that what's actually happening? Well, we don't know. All we know is that that model allows you to predict that when you throw rocks at windows, they break. That's all it does. It doesn't say anything about anything else. Now, for instance, here's another way this works. There's a picture of an electron or a schematic of an electron. It's an electron as a little spinning red ball with either an up spin or a down spin charge, minus one charge. Except that electrons aren't balls, they don't spin, they don't have charge, they're not particles. Or sometimes they are and sometimes they're not. So if you want a more precise definition of what an electron looks like, then use the mathematical formulas in the lower right. However, even the mathematical formulas use all these symbols, Greek letters, things which don't strictly have anything to do with electrons. They're conventionalizations for mathematical descriptions. So what is an electron? Nobody knows what an electron is. They know it has spin because MRI machines work. Now, are they actually spinning? Sort of. They're not spinning like this. They're spinning like electrons spin, which is not quite the same thing. Do they have charge? Yes. What is charge? Charge is this thing that we notice when you put something with a positive charge next to something with a negative charge, they attract each other. And so we decided to call one positive and one negative because if you put two negatives together, they repel each other, and like things attract, or like things repel, and different charges attract one another, and so that's charge. Okay, so, but it's not charged like a battery's charged? Well, kind of, it's kind of like that. So the long and short of it is that all science ultimately has to rely on models and analogies to say anything about anything. Does anyone know the best definition here's a definition of philosophy for you, okay, ready? Philosophy is asking questions like a child and answering them like an attorney. So, and here's the ultimate example. When your child asks you, Mom, what is real? That's a simple question, right? Does science determine what is real? Well, it depends on which philosophy of science you want to believe. Does it just approximate reality? Does it make useful models? Is anything even proven to exist by science? Okay, now here's where we start talking a little more about my Bible. Does the Bible tell, who here believes the Bible tells you about God? Okay, who here believes you have a comprehensive picture of God based on what's in the Bible? Yeah, so I know people are afraid to answer that one. Let me go so far as to say this. The Bible itself tells you that the Bible doesn't tell you everything about God. John 20, these things have been written so that you may believe Jesus is the Christ. Not everything, I don't remember the exact quote, but not everything here has been written that Jesus did. I suppose if everything were written, the whole world wouldn't contain all the books. So right there, did John write down everything Jesus did? No, he tells you right there he didn't do it. Now we see in a mirror darkly, but then we shall see face to face, and then we shall be known even as we are known. So that's what Paul, 1 Corinthians 5? There's an interesting parallel here between science and theology. Both of them don't really describe a reality in its essence. Presumably, God knows what an electron actually is. Whether you are a particle physicist or not, the best you can do is create models that are helpful in making predictions and that guide future research. That's not nothing. I'm not dissing particle physics here. That is an actual thing that actually is helpful. It makes MRI machines, for instance. So hey, that's useful. So that's a good thing. But no one has ever, let me put it this way, no one here has ever seen an electron. Now you may say, hey, I saw a picture of an atom in a book the other day. A, it was a picture of an atom in a book. B, even if you were at the lab that made that picture, you would know that that's not a picture of an electron or an atom. That's a mathematical reconstruction on a cathode ray tube or a LCD screen of a bunch of data that represents what an atom would look like if you could see an atom. So no one's actually seen an atom. Again, God knows presumably what atoms look like. I don't think, my argument would be even after Jesus returns and we're all in our resurrection bodies, you're still not going to be able to see an atom. You can ask God about it. And for that matter, you could probably spend eternity studying it. So, and I would argue that the same is ultimately true of theology. I'm going to pick on Elizabeth because I know her dad. Is God your father? Oh, her guard is already up. Okay. Oh, you're thinking too hard. Okay, so we'll say yes. You already know where I'm going with this. Okay. Yes, yes. Bart is your biological father. Heavenly Father is not your biological father, but is your father in a different sense. So does that mean there has no correlation between your earthly father and your heavenly father? No, they're kind of alike in some respects. But your dad would not claim to be your heavenly father, and for that matter, your heavenly father would not claim to be your biological dad. So all theological language is also analogical to a certain extent. So no one, again, you see it in the Bible, no one has seen God. Okay, but he who has seen me has seen the Father. Okay, if you see Jesus, as someday you presumably will, have you seen God in all his glory? No. I mean, you've seen Jesus, and that's more than enough. That's plenty. But you have not seen God in all his glory. So the picture on the right there is the beatific vision in Dante's Paradiso. Has anyone here read Dante? I think everybody should read Dante at least once. So it's very Catholic, but if you get a good annotated version, it's actually pretty profound. So Dante talks about the beatific vision. It shows up in not just Catholic mystics, there's a few Protestants too, where they see God. Now the thing that tends to unite all these visions is that no one's willing to talk about it. There was this guy, I know a man in Christ who 14 years ago was caught up to the third heaven, which is to say the heaven where God is. Whether in the body or out of the body, I do not know, God knows. And I know that this man was caught up into paradise, whether in the body or out of the body, I do not know, God knows. And he heard things that cannot be told, which man may not utter. So who said that? Paul, yeah. So even Paul had this vision. And the Greek is a little ambiguous whether he can't say, like I can't say, like I'm not allowed to say, or can't say as in it's not possible to say. But in any case, he couldn't say. So even he, in some sense, saw God, but can't explain it. One of my favorite quotes from, here's bonus points, anybody who knows where this came from. Who is so devoid of intellect as to not understand that God, in so speaking, lisps with us as nurses are wont to do with little children? Such modes of expression, therefore, do not so much express what kind of being God is, as accommodate the knowledge of him to our feebleness. In doing so, he must, of course, stoop far below his proper height. Does anybody know who said that?
C.S. Lewis.
Close. John Calvin. So the idea is that even when God directly reveals himself to us, he's got to sort of shield his glory. Another one of my favorite stories is, y'all remember Moses on the mountain, and he says, God, show me your glory, and God sticks him in the cleft of the rock and says, I'm going to pass by, but you only get to look at my backside. And Luther makes great sport of this, and that, we only get to look at God's rear end, that anything else is going to vaporize you. So just be happy with that. Now, this is, the good news, bad news is that sometimes this idea of both theology and scientific knowledge being analogical is sometimes lost on, of all things, scientists. This is one of the more unfortunate things that Neil deGrasse Tyson says, and he's actually gotten a lot of grief for this, not just from Christians and religious people, but actually from skeptics and IFL science people and all this. One of the signs of the second coming is that stars will fall out of the sky and fall to earth. To even write this means you don't know that those things are. You have no concept of what the actual universe is. So everybody who tried to make proclamations about the physical universe based on Bible passages got the wrong answer. Well, that may be technically true, but the difficulty is that's not what apocalyptic literature is trying to say. So why is an astronomer giving us lessons on biblical interpretations? Does Neil deGrasse Tyson even know what apocalyptic literature is? Apparently not. There's lots of other examples. Stephen Hawking, of all people, and a colleague of his, Mlodinow, wrote a book called The Grand Design, where they spend the first chapter describing how philosophy is dead and philosophy doesn't matter anymore. Then they spend the next three chapters doing bad philosophy. So it's actually not a bad book overall. You just kind of got to skip ahead. One of the things I would say, sort of pieces of advice I would give people who are digesting scientific literature or anything that a scientist says, is be aware that if you have your PhD in human physiology and you're talking about human physiology, you should probably listen to that person. To put it bluntly, if I'm up here telling you what anesthesia is and how it works and what you should do to prepare for your surgery, you should probably listen to me. If I'm up here talking about how to repair your car or how to frame a house, you should probably not listen to me. I have done both those things. I know what motor oil tastes like, because when you're unscrewing the little thing like this, yeah, okay. So don't listen to me on that kind of stuff. The unfortunate fact is that you give somebody a big platform, and it's very easy to talk outside your field of expertise. Such as, and like say, Neil deGrasse Tyson, unfortunately, has been kind of skewered for doing that repeatedly. And Stephen Hawking and Richard Dawkins do it too. Just some more general caveats about how science works. Even just the simple act of making observations, besides being theory-laden, making an observation as an archaeologist and making an observation as a particle physicist are completely different things. So in fact, it's to the point where if you're an archaeologist and you're a world-class archaeologist and you step inside a particle physics laboratory, you are pretty much useless. You might be able to mop the floors. That's about all you're good for. Finally, well, we've kind of already covered most of this. It's never as simple as moving from observations to hypothesis. There's an entire process, some of which is explicit. I have to do literature research, I have to do literature searches, I have to discover what people have already done, I have to discover what dead ends haven't worked. I talk to my colleagues, even about things that weren't published, things that they tried and that they gave up on, so that I'm not doing the exact same thing all over again and also giving up. So all these things happen, and most of that is out of the public eye. Some sciences are very experimental and some are not. You pretty much can't do experiments in astronomy. The Eddington experiment was kind of unusual because it was actually kind of an experiment that they did. Now, you can't change the location of the sun or the moon or the stars, but you can at least travel to part of the Earth and make some predictions about it. Finally, has anyone here heard of the replication crisis? Crisis in replication. It's most famous in psychology. There's a lot of psychology experiments in particular, many of which are still in psychology textbooks. If you just take your basic psychology 101 class at CRC, you will read about these experiments. And what people are discovering is that a lot of these experiments were never replicated, and they're just wrong. They just don't work. Now, again, that's not to say that psychology is bunk. It's just to say that some psychology research is better than others. So, for instance, one of them that gets a little bit of press, has anyone heard of the Stanford prison experiment? It was where a Stanford psychology professor took a bunch of undergraduate students, made some of them arbitrarily prisoners, quote unquote prisoners, and made some of them arbitrarily quote unquote guards, put them in the basement and had them live together for, I think it was about a week. And what happened was they stopped the experiment early because the guards were basically turning into monsters and the prisoners were being psychologically traumatized. So it's basically the idea is if you give somebody enough power and you dehumanize other people, then it's real easy. Even if you are the most mild-mannered English literature major, if someone gives you a jackboot in a club and tells you that that person over there is a prisoner and they're less than human, then you're still willing to kick them. Now, there probably is some validity to this experiment because they've done some similar things to it. However, people have literally replicated that exact experiment and come up with very different results, where everybody just kind of gets along and the prisoners are there drinking their Diet Coke sitting right next to the guards and everybody just kind of says, so what are we doing here for the next week anyway? That gets worse in big science. If you are going to spend $10 million or $100 million on an experiment, then who's going to replicate that experiment just to make sure you were right? Nobody. So the most that can be done is they can criticize your protocol, look at your data, see if everything makes sense. But what they're finding now, especially with the advent of AI, is that you can run an experiment, get lots of data, and if your data doesn't quite line up, you can probably find an AI bot somewhere that will create some more data and fill in some spaces, and your research, which was just kind of meh before, now suddenly becomes really solid. Wow. And again, who's going to check? So this is not a counsel of despair because nobody knows the temptation of this more than your typical graduate student. Unfortunately, also your typical graduate student probably knows somebody who's done it. Finally, what do scientists really spend their time doing? If you are a super nerd and you know everything about particle physics, you're probably not going to make a very good particle physicist unless you also know how to manage people, write papers, write grants, show up at conferences, talk in front of a group, get along with people. What do you do when one of your lab assistants says the other lab assistant is making inappropriate comments about them in the lunchroom? Those are things, unfortunately, that you get to spend some time on as a scientist. Do you want to take a break now? Let's take a break now. And then we'll talk about sort of formal ethical issues in science, why you shouldn't set your lab assistant's hair on fire. Even though it happened in Muppet Labs all the time. As usual, there's too much to get through here, but we will hit some of the high points. And I will also hit one more big mind-stretching concept that I think is important in the grand scheme of things that will help you out next week and the week after that and the week after that and for the rest of your life. Anyway, if we're talking about what scientists actually do, eventually science, ethics in science comes up. And I won't spend a lot of time on this because most of you at least know this in the general sense. Do people here know what eugenics is? Yeah, it got its worst rap probably in the 1940s. I mean, the Nazis were, very explicitly eugenic. Guess where the most advanced eugenics program of enforced sterilization and selective breeding, guess where what country the most advanced program was in 1935? The United States. Yes. One of the books on the little list down there called The Nazi Doctors is, I think, one of those things everybody should read. It's very accessible, and if you're at all into 20th century history, it's both really interesting and kind of disturbing for obvious reasons. But yeah, the Nazis were looking at the United States in 1935 and saying, we got to do that. Yeah. So it was, the ideal model was that they wanted to be able to identify people who should not breed, either because they were criminal or really stupid or deformed or something, have them come into a government office to fill out a form, and they would come up to the counter and fill out a form. Meanwhile, their genitals were being irradiated with enough radiation to sterilize them. Wouldn't that be cool? No, yeah, and you read the stuff like this and you're like, wow, people were like actually planning this. And people would go home and say, why do I have a weird sunburn where the sun never shines? It's like, well, anyway, those are the obvious ones. MK, has anyone here heard of MK Ultra? Yeah, it was kind of a joke for a while. It was on the X-Files, and it turns out that it was one of those rare cases where the conspiracy theorists were actually correct, that the CIA really was giving people LSD and seeing if they could turn it into a truth serum. So these are the obvious ones. The Tuskegee syphilis experiment, that's probably the most famous one that gets talked about in classes about scientific ethics in particular. You enroll several thousand black men who have syphilis and tell them they're going to get treatment, and you don't treat them because you want to see the natural progression of the disease. And this just so happened to be in Mississippi in the early 20th century. The reality is that most scientists don't have to deal with things like that. What they deal with is things like, how do I report negative results? How do I fund my lab when they've cut my grant budget? Not that that's an issue these days. Just personal issues. Does anyone remember the astronaut who drove across 4 states, supposedly wearing astronaut diapers in order to attempt to kill her romantic rival? Yes, that's not strictly, but they were scientists, so that wasn't part of a scientific research study, but things like that do affect your work environment. So what are the implications of all this? I don't want to sound like I'm dissing science through all this. It's still a good thing. I'm generally speaking a science booster. There's another book on there called Factfulness, I think it's called. Largely thanks to science, things really are better than they were 200 years ago for almost everyone. So unless you're in North Korea or Sudan, then actually things are better today, largely thanks to science. And I only realized this in reading through that book. Even as recently as 150 years ago, if you were living in Sweden, we think Sweden as being this kind of this is the secular paradise. This is where everybody gets taken care of and nobody's out of a job and everybody has a house and the prisons are like country clubs even. 150 years ago in Sweden, the likelihood of your starving to death was actually pretty decent. And that has changed now largely as a result of science. One other thing, regardless of what you think about COVID vaccines, that whole Operation Warp Speed was really kind of amazing. It took science about 9 years to develop a measles vaccine once they realized what measles was. It took polio about 22 years, yellow fever about 25 years, and COVID vaccine took about 12 months after the WHO said it would take 18 months. So whatever you think of Donald Trump or politics or the CDC, it was pretty amazing that they got that far. There's another link on there if you want to hear the inside story. There's a podcast by Francis Collins on there that talks about, and Francis Collins obviously is very much, he's a scientist. He works in vaccine research among other things, but his podcast, he also kind of talks about some of the missteps which relate very directly to what we're talking to today, in the sense of science is about research and coming up with useful models to make predictions and to create cool stuff that we can all use. But it's also about personalities, and it's about public perception, and it's about funding, and it's about politics, and it's about a lot of stuff. So, and that particular podcast gives you a really good example of how that all works. So is science all corrupt and horrible? Well, some of it certainly is. As Christians, of all people, we should be unsurprised at this. Even the church is pretty terrible too sometimes. And a drum that I bang all the time is that particularly American Protestants, particularly American evangelical Protestants, tend to have a really poor view of common grace. Do people know what common grace is? Anyone? God causes his rain to fall on the just and the unjust. So to put it bluntly too, the way this works out in reality is if you have cancer and you go to, and your primary care physician says, we got back the results of the biopsy, it's not good, I'm going to refer you to an oncologist. He's a really good oncologist. He knows all about this stuff. He treats this particular kind of cancer. Is the next thing out of your mouth, well, I might be willing to see him, but is he a Christian? Now, maybe you say that. Most people don't. Most people say, if he's a good oncologist, then I will see him. So that's common grace. So basically it argues that just because you're not a Christian doesn't mean you're an idiot. Okay, so in other words, is science a Christian endeavor? Well, no, although I would argue it's Christian in a very fundamental way, but we'll get into that next week and the week after that. But that doesn't mean that it's always wrong, and that it's always venal, and it's always stupid, and always a conspiracy theory meant to corrupt everyone. Science does have its issues. Generally speaking, no one is more aware of this than other scientists. The example I always like to use is I go to a conference pretty much every week where they present research findings about new projects in anesthesia, some of which are directly related to the University of California and some of which are not. But it is standard at the start of every presentation, you have to give one slide explaining how you are related to the research that you are doing. For instance, there's a guy in our department who works for Medtronic, creating a nerve stimulator for checking how paralyzed people are. He has to put that in there. I own stock in Medtronic. I'm employed by them in the process of doing this research. Now, everybody looks at that and says, that doesn't mean that his research is useless, but nor does it mean that you should just take everything at face value. And there's a good chance that next week somebody else is going to show up and say, thank you to Dr. Epstein for his wonderful presentation last week. Here's some things that we might want to consider. So nobody is more aware of potential conflicts of interest than other scientists. And if you talk to Dr. Epstein himself, he will tell you that's an ongoing issue, that he has to come up with positive results that make Medtronic look good. And if he has negative results, then part of his job is learning how to spin that in such a way that they will continue funding him even though their stupid device doesn't work. And he will tell you that's pretty much an exact quote right there. What I tell people is I encourage people to look at science the same way the reformers looked at Roman Catholicism. So you affirm the good, you appreciate the history, avoid their errors. Humility is more important than pride. Trust in God rather than my own strength. Trust but verify. Does anyone know where that expression comes from? Yeah, Ronald Reagan, yes, in the midst of SALT II, I think it was, the Strategic Arms Limitation Treaty. The irony is that trust but verify is a Russian proverb. That's true fact. So, and whatever you do, please try not to exacerbate the crisis in institutional authority. If you don't like science, that's fine, but try and criticize constructively rather than just burn it all down. So when it comes to the general public, people are bad at science. But there is a reason why getting a PhD is considered entry-level science. So if you're going to be a research scientist, you pretty much have to get a PhD. If you have a master's in something, then that will get you working in a lab and even doing something constructive. But the Dunning-Kruger effect is very strong at work. Do you remember what we talked about last week, the Dunning-Kruger effect? If you read 3 science articles, you're an expert. If you read 5 science articles, you are really an expert. If you actually enter a science program, then by the time you're a junior in the program, you'll realize you know nothing at all. Just some common advice. The problem that you run into is if I'm standing up here telling you have to have a PhD in science to understand science, but that won't happen, therefore you won't understand it, well, what are you supposed to do? Well, appreciate limitations, appreciate common grace, appreciate that you can learn some things, and choose your authorities wisely. That whole expression I gave you about if you can't figure out what someone's qualifications are, they probably don't have any. That seems to be, I'm kind of an old guy. That seems to be generally true. And that's even true outside of science. If you start attending a new church and you can't figure out where the pastor went to seminary, if anywhere, or where he went to school anywhere, or what he did with his life before he became pastor of the Victorious Life Church, then he probably should run away. So, and the same is true in science. Here's the final big topic I'll give you before we that will explode your head. That will explode your head before we go. Can anybody here give me a good definition of what eschatology is?
Study of.
Yes, it's the study of the end times. Yes, but it's much broader than that. Now, for some people, it's like charts about Israel and the rapture and all that kind of thing. Yeah, that's eschatology, but I'm using it in a much broader sense. The idea of what is the chief end of man? Where is this all headed? The classic, and there's generally speaking, you'll hear this goes back, I want to say, to Walter Wangerin. It may be even earlier than that. Several theologians, late 20th century. They will talk about overrealized eschatologies, underrealized eschatologies, and inaugurated eschatologies. Now, before this, let me give you a concrete example of an overrealized eschatology that everybody's familiar with, and that's the prosperity gospel. Now, it's true or false. God wants you to be healthy, without lack, and living a meaningful life in good relationship with the people around you. True. So, is that true for everyone here today, right now? So, you don't have enough faith, in other words. No, I know what it is. Write me a check for $1,000, and I promise that God will double that for you within the next week, because it says right there in the Bible. Bring your full tithe into the Lord, and He will prosper you. Doesn't it say that in the Bible? Of course it does. So therefore, there you go. So that's an overrealized eschatology. That's prosperity gospel. Is there going to be a day when your back doesn't hurt, and you have good vision even without your glasses, and you're in good relationship with the people around you, and you don't wonder where you're going to get food from? Yes. And that's going to hit its ultimate reality with Christ's return. So to think that that's going to happen tomorrow morning, unless Christ returns tomorrow morning, which is not impossible, but we'll argue that for the sake of argument, it doesn't happen. That's not going to happen tomorrow morning. There is also an under-realized eschatology, which is much less common. About the only place that I see it routinely is occasionally I'll talk to people at work who are from a very hardcore Roman Catholic, mostly kind of Filipino background, where they can never make God happy. They say the rosary, they go to Mass all the time, they are confessing constantly, and God is just perpetually angry. And there's just nothing they seem to be able to do about it. That is an under-realized eschatology. In other words, did Jesus pay the penalty for your sins on the cross or not? If the answer is yes, then guess what? God is actually not angry with you. Now, that doesn't mean God might not be a little bit irritated if you're in the middle of sinning, but even so, Christ paid the penalty for that sin. So knock it off and move on with your life, and don't give into a worm theology that I'm just so worthless that it's amazing that God even puts up with me at all. That's an under-realized eschatology. How does this relate to science? Well, because this is the future that science is going to give us, at least according to some people. So this is the Gene Roddenberry future, Star Trek. That if science just advances far enough, then we're going to get rid of all hunger, all want, all disease. We're all going to be healthy, wealthy, and wise forever. That's a classic over-realized eschatology. It's just a secular eschatology. It doesn't have God involved. So, and the other way you see this, particularly online, is everything would just be so great if all these science deniers would just get out of the way. So the solution to that is an inaugurated eschatology, an appreciation that neither vice nor virtue are the exclusive reserve of Christians or non-Christians. You can be a non-Christian person and be a good person. Now, that doesn't mean you're not under the wrath of God, but it can still mean that you can be a really good oncologist. You can be a compassionate, research-driven, working hard for your patients, making sure that they do as well as they can. When things are hopeless, you'll be there holding their hand as they drift away. That you can still be a really good oncologist and be a Hindu or a Muslim or an atheist. It is possible and happens all the time. And on the other hand, unfortunately, you can also go to church every Sunday and be a real kind of jerk. So an inaugurated eschatology realizes this is true, that there is good, there are wheat mixed in with the tares, that you're not necessarily going to be able to tell the difference all the time. The other thing to note, however, and I would bang this drum a little bit, and a book I forgot to put on there is something by Rodney Stark and or Tom Holland. Science arose in a Christian context and with ultimately Christian assumptions. Steve and I were talking a little bit about this on the break, that there's a pretty good argument you can make that if Christianity had not arisen in the Roman Empire around 30 AD, then science today would not exist. The people that make this argument explicitly are Rodney Stark, and there's a book called How the West Won, another book called The Victory of Reason. Tom Holland, he's explicitly an atheist, and he wrote a book called Dominion, which basically says that if Jesus hadn't come and hadn't taught the way he did and did what he did, then we would still be living kind of basically in the warmed over remains of the Roman Empire. And if you had a baby and you didn't like it, then you throw him on the trash heap. So, and if you are kind of bored, then you'll go to some gladiatorial games and watch some people be executed, and that's just all cool. And one of the concerns for the future of science is that as Western societies are sort of hollowed out from the inside, when Christianity stops being such a big deal anymore, then it will lose that moral bearing. Some people would point to, for instance, a lot of reproductive technology as being something where that's kind of being hollowed out from the inside. The important thing is to have a baby that I like, not to just have a baby that I value because he's made in the image of God. But we'll cover that in the last class. There is a term for this kind of over-realized eschatology that you'll sometimes hear called scientism. And sometimes I'm accused of making this word up. It's not a made-up word. It's even in the Internet Encyclopedia of Philosophy. Basically, it says that science is the only or even the best way of knowing things. That if something is not scientific, you can't believe it. Now, germ theory, you can believe that because that's science. The Bible, you can't believe that because it's not science. Okay, you can believe it, but it's just kind of your personal opinion. If it helps you get through your life, if it's good therapy for you, then you can believe it, that's fine. But let's not confuse ourselves and think that this is an actual assertion about the nature of reality, because it's not science. Okay, that would be scientism. It's rampant in popular culture. So, I mean, you pretty much can't turn on the TV or the internet and not see it somewhere. Most science versus religion controversies are actually conflicts between pop Christianity and science, or between scientism and non-materialistic worldviews like Christianity. So let me ask you this question. This is another one of those philosophy questions, asked like a child, answered like an attorney. What is the most common way that humans come to know things?
Experience.
Experience, that's one possibility. What's more common than that even? Taught, which is authority, essentially. Now, why do you believe that 2 plus 3 equals 5? If you have a graduate degree in mathematics, particularly in philosophy of mathematics, you might be able to make an argument that 2 plus 3 equals 5. Otherwise, the reason you believe 2 plus 3 equals 5 is because your second grade teacher told you that 2 plus 3 equals 5. So most things that most people know are based on authority. This is true for scientists too. If Stephen Hawking wanted to know the mass of an electron, what did he do? He went to Google. He went to a reference text, the CRC or something like that. He looked it up. He trusted somebody to give him the right number. He did not repeat Millikan's oil drop experiment that was done in the early 20th century to determine the mass of an electron, because that would be really complicated and really difficult and didn't give you great results anyway. So most people believe most of what they believe most of the time based on authority. That includes scientists, that includes science popularizers, that includes philosophers, that includes priests and pastors, that includes essentially everyone. So scientism is just wrong on its face. You don't believe things because science proved them to you. You believe things because someone told you that science proved it to somebody at some point in the past. And that's a hard pill for a lot of people to swallow. But if you really had to prove everything from first principles, then humanity would have never gotten out of the Stone Age. So, and we'll talk more about this in our last class, but scientism is basically when you get popularized science combined with philosophical materialism. Philosophical materialism, that's the Carl Sagan philosophy. The universe consists entirely and exclusively of nothing but matter, energy, space-time, and unchangeable physical laws, and that describes everything that exists. So obviously there's no God, there's no soul, there's no angels, there's no demons. The interesting thing, and this is one of the more controversial things, materialism is often tacitly assumed within the church. What do I mean by that? There's a class at the hall on spiritual warfare. That's a great class. I would not be the slightest bit offended. If you decide this class isn't for you and you want to go over there next week, then go for it. You have my blessing. The fact that we have to have a class on spiritual warfare suggests that most people in the church are operating out of the standpoint of philosophical materialism. It's like, ooh, we're going to talk about demons now. Ooh, that's spooky. If you went back to 13th century France and said, okay, we're going to talk about demons now, then everybody would be like, yeah, what would you like to know? I mean, it was a lived experience for most people. The book that I would recommend that everyone try to read and that 90% of people will fail to read is a book that's on your list there called A Secular Age by Charles Taylor. Probably the most important book published in the 21st century so far. It explains how we got from 13th century France to today. It's about 450 pages. It's dense. I mean, I have an undergraduate degree in literature with a heavy emphasis on history and a graduate degree in philosophy and theology, and it was slow going. It is deeply important, however, in that it really shows that there's a fundamental difference between what people in France thought in 1350 and what people in France thought in 1850. And it wasn't just sort of like one person has a God and one person doesn't. It's a whole, the expression he uses is social imaginary. It's one step deeper even than worldview. It's things you assume to be true about the world. Materialism is the default assumption for most people today, even including in the church. Now in the church you fight against it and say, no, we can have a class on spiritual warfare. Whereas in the wider society it's like, why bother? I mean, there's no such thing, why bother? So, and here's one thing that a couple people brought up. Can you do this is an example of kind of runaway materialism and scientism, even in a very respectable journal, the National Library of Medicine. This was originally published in, I don't remember where. Study of the therapeutic effects of intercessory prayer, STEP. All medical research today has to have a cool acronym, the STEP studies. Study of the therapeutic effects of intercessory prayer in cardiac bypass patients, a multi-center randomized trial of uncertainty and certainty in receiving intercessory prayer. Wow, multi-center, randomized, this is good science. Wow, this is great science. Okay, what's the problem with this study? Yeah, one of the fundamental problems with any experiment is you have to control for variables. If you're trying to grow one plant in one type of soil and another plant in another type of soil, that could be a really good experiment unless you let the janitor come in when you go home and mess and move the plants around and pour things in the soil and mix things around. Then you just ruined the whole experiment. You can't run an experiment on intercessory prayer that works. It's not physically possible because there's a variable you can't control for. What is that variable? God, yes, God is notoriously difficult to control in an experiment. So the interesting thing, and this is a classic case of if you actually go into the study, they had people praying, and they were praying to God. And if you look at their backgrounds, it was almost entirely essentially kind of a New Age church, kind of Unitarian Universalist, kind of like God is an energy force. And if we speak positive things in God's direction, he's required to do those positive things. Kind of, prosperity gospel, word of faith kind of thing. I don't know about you, I don't think that kind of God exists. So anyway, it was a good try. But it's a classic example of, and I don't know how many times I've discussed this study with people online. It's like, hey, look, science shows that prayer doesn't work. It's like, no, the study shows that these particular scientists don't know how to construct a valid experimental design. That's what it shows. Anyway, so final thoughts. Epistemic humility. Notes, be humble about what you know and what you don't know. What are some biblical grounds for trusting authority in science or anywhere else? I would argue that, this is a little controversial, but I would say that you do know them by their fruits. What I mean by that is there is no such thing as morally neutral knowledge. Now, if this brilliant oncologist you get referred to is on his third wife and is thinking of leaving her and has a heavy gambling habit, that doesn't necessarily mean he's a terrible oncologist, but it would give me some pause. Now, most of the time you're not going to know that. And on this, for this study, Herbert Benson, Jeffrey Dusick, Jane B. Sherwood, Peter Lamb, Charles Bethea, William Carpenter, Sidney Levitsky. I don't know about anything about any of these people. You can look up their CVs online if you want, but I know nothing about their personal lives. But again, if somebody is a real jerk, chances are they don't run their lab very nicely, which means chances are their research is not great. So again, that doesn't mean just because somebody's a jerk, their science is useless, but it is something to keep in mind. Finally, appreciate that life is short, you're not that smart, and that the universe is a very complicated place. Sunlight is the best disinfectant, meaning if you have a tendency to read nothing but right-wing-ish sources about science, then read some left ones, and if you have a tendency to read nothing but crunchy granola mom sources, then read some right-wing things for a while. Better yet, find somebody who knows about the right, knows about the left, and is trying to avoid both of them. Some concluding thoughts. This is, you'll hear more about this later. This is C.S. Lewis. There is something which unites magic and applied science, by which he basically means technology, while separating both from the wisdom of earlier ages. For the wise men of old, the cardinal problem had been how to conform the soul to reality, and the solution had been knowledge, self-discipline, and virtue. For magic and technology alike, the problem is how to subdue reality to the wishes of men. So that's the problem in a nutshell. And again, we'll spend all of our last class talking about this. This is the darker side of where science is at least potentially going. So finally, know your own biases. Are you science suspicious or science trusting? Which of these pictures best reflects your view of what scientists look like? The noble knight, the Illuminati scoundrel, or the clever idiot? So, and whichever one of those things you think it is, work on finding a different view, because it's never quite that simple. Have we given enough to explode your head? Let's see, we lost about 20% people last week, so that means next week we'll be down to... Yes, yes, I know mission will have succeeded if we're down to 12 people by the last class. No, not really. The last class is actually the most interesting. I had a brain explosion last night working on it. So AI is going to usher in the second coming. Anyway, don't worry, I'll share with you the details later. Oh, does somebody want to close us in prayer? I'll let somebody else do that. Who wants to do that? Anybody want to volunteer?
Almighty God, we just thank you for this time, for these people to come together, just to balance our thoughts. We all want to be able to speak intelligently to people who are lost and bring people to your throne, to your grace, or to salvation. I just thank you for Tom and just the effort that he's put forth. Thank you for those people for just the desire to grow. Thank you for this, and Lord, we just use this, what we've learned, little seeds that we planted in conversations this week. Bless this week. Just thank you.